Good morning, grade 12. This is Mrs. Pascale. Today's section is about indefinite integrals, part 5. The objective is to calculate indefinite integrals using substitution rule. Calculate the following indefinite integrals. For example 1, integral of 4x into x squared plus 5 to the power of 3 dx. Using the substitution rule, we need to take supposition for the expression with the highest power. So let u equal x squared plus 5. The derivative over u is equal to x dx. Rearranging the integral, since we don't need the constant 4, we can take it outside the integral and write 4 integral of x into x squared plus 5 to the power of 3 dx is equal to 4 integral of 2 over 2x into x squared plus 5 to the power of 3 dx. We need to introduce 2 since the derivative over u is equal to x dx. Then taking half outside the integral, we get 4 over 2 integral 2x into x squared plus 5 to the power of 3 dx. Reducing and replacing in terms of the new variable u, we get 2 integral u cubed du. Calculating this integral, we get 2 u4 over 4 plus c. Reducing and rewriting the answer in terms of x, we get x squared plus 5 to the power 4 over 2 plus c. In example 2, integral of x cubed e to the power x4 dx. We need to take the supposition for u equal x4. So du is equal 4x cubed dx. We have a missing value, which is 4, so we multiply and divide the expression by 4, and we get integral 4 over 4 x cubed e x4 dx. Since du is equal 4x cubed dx, so 1 over 4 need to be written outside the integral, and we get 1 over 4 integral 4x cubed e to the power x4 dx. Substituting with respect to u, it's equal 1 over 4 e to the power u du. Calculating this integral, the answer is 1 over 4 e to the power u plus c, and at the end we need to replace u in terms of x. We get 1 over 4 e to the power x4 plus c. Integral of sine square of x cosine x dx. In the integration of trigonometric function, we need to take the supposition of the highest degree, so take u equal sine x. The derivative of u is equal cosine x dx. So replacing directly in the given integral, we get integral of u squared du. The answer of this integral is u cubed over 3 plus c. At the last step, replace u by the expression in terms of x. We get the answer sine cube x over 3 plus c. In example 4, integral of cosine 4x sine x dx. So let u equal cosine x, then the derivative of u is equal minus sine x dx. Multiplying by two negative signs, we get minus integral minus cosine 4x sine x dx. So it's equal minus integral u4 du equal minus u5 over 5 plus c. And at the last step, we replace u by the expression. We get minus cosine 5 of x over 5 plus c. Example 5, integral of 9x squared over square root of x cubed plus 7 dx. Substituting by the highest power, so we need to take u equal x cubed plus 7. The derivative over u is equal 3x squared dx. Before replacing in the integral, we need to write it in the form of product of expressions. And since it's obvious that we don't need the integer 9, we can write the integral 9 integral x squared into x cubed plus 7 to the power minus half dx. Since the constant 3 is missing, multiply and divide by 3 the integration. We get 9 integral 3 over 3x squared into x cubed plus 7 to the power negative half dx. Rearranging this integral, we get 3 integral u to the power minus half du. The answer of this integral is 3 u to the power half over half plus c. Reducing the answer, we get 6 u to the power half plus c. And finally, replacing u by the expression, we get 6 into x cubed plus 7 to the power half plus c.